Hello, 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 ladies and gentlemen, boys and girls. Welcome to VUX World. 3 weeks out to UNPARSED. 3 weeks, that's all it is. We are putting the dots on the I's and the crosses on the T's, or whatever which way that goes. And we are running full steam ahead. We've still got some promo codes available on VUX World if you do want to attend. I know there's been a lot of people hitting us up. A lot of online tickets being sold. We've got more people going so far than we had last year, which is great. Venues bigger, more capacity, which means we can get more people in there. Obviously, we've now got the dev track as well, so we've got a whole new track this year for developers and for the more technical practitioners out there. So in 3 weeks, we will be uniting the conversational and generative AI communities under one roof at the Museum of London, sharing best practice, case studies, insights, and emerging best practice as we start to deploy and develop more with things like generative AI and large language models. What does it mean for conversation designers? What does it mean for developers? What does it mean for businesses? And how can we make sure that we leverage this stuff effectively, responsibly, and successfully? And that is exactly what we're going to get into at UNPARSED. And you can go to unparsedconf.com for your passes today. Pay attention this week also on the socials. I'm learning it's called the socials now with the Ute Dem. Pay attention on the socials because there's going to be a exclusive UNPARSED wrap dropping very soon. So keep your eye out for that. VUX.world/subscribe if you want to get updates to all of these podcasts and all of these events. And without let's crack on, shall we? Let's welcome today's guest, Ricardo Herreros-Symons, who is the VP of Strategy and Corporate Development at Speechmatics. And we're going to get into the missing piece in many people's AI strategies and technology stacks, which is speech recognition. The role that speech recognition plays, the kind of use cases that it enables, and some really interesting trends and analysis and updates from Ricardo. So without further ado, ladies and gentlemen, please welcome Ricardo to VUX World. Hello there.
Hello, how are you doing?
I'm very good, thank you. How are you?
Yeah, not too shabby,
Good. Thank you for joining us.
Hey.
Say again?
Be nice, the weather a bit nicer than other ones.
Yeah. We had a good couple of weeks in Harrogate, where I am, and the last few days it's just gone back to what it was, which is just pissing down every day. Anyway, never mind. Thanks for joining us anyway, Ricardo. I know we've been trying to do this for a while, and so it's really good for you to join us, and appreciate you spending some time with us.
Yeah, delighted to be here. As I say, very excited to get the conversation going. So.
Likewise. So tell us about Speechmatics then, for those that don't know, if they've never heard of Speechmatics, what does Speechmatics do? And maybe also a little bit more about yourself and your role there.
Yeah, I guess the thing about Speechmatics is that sort of I'm so entwined with the business that who I am and who they are, so it was hard to sort of bring the two apart. What I might do is sort of just give a very little demo whilst I talk, if that's okay, because then it should bring to life what we do. So
good idea.
Assuming I'm still able to the real work for a tech company, so I should be able to share a screen with you. But let me know if you're able to see that.
It's coming. Got it. Yeah. Here we are.
So what I am going to be doing here is I'm just showing you our automatic speech recognition system. So what Speechmatics does, and what I've been doing for the last 10 years as one of the founding team at the business, is turn audio into words in its most basic format. What you notice here is that lots of people do speech to text. Obviously, the likes of Google, Amazon, Microsoft, Apple, and more recently, sort of OpenAI as well. But we like to differentiate in a few certain ways. So you'll be able to see, as I'm speaking, these words are appearing. It's also being translated into Spanish at this point in time. But we separate ourselves in a few different manners. And first of all, we've always been the number one in terms of accuracy. We really want to make sure that we can understand every single voice. And in order to do that, we ensure that having low latency, sort of really human interaction and really high quality speech recognition is what you get. So I don't want to spend too long talking about us, because I know we want to talk about things in general, but just to give you a couple of ideas on that differentiation. First of all, we have much broader vocabs than other providers in speech rec. So what I'm going to do here is just give you a little example. So this is a song I learned when I was slightly younger, describing some drugs that you get in the UK, not US ones. And they're all legal ones, so it's okay. But yes, so very quickly, there's aspirin, adrenaline, and also aminophylline, amphetamine, adenosine, augmentin, and rifampicin, amoxicillin, penicillin, heparin, and warfarin, and estrogen, progesterone, and canesten, and chloroquine. There's benzoyl-thiazide, and also cyclophosphamide, metoclopramide, acetylsalicylate, tropicamide, loperamide, cytosine, and frusemide. And I really wouldn't recommend drinking formaldehyde. Now, most systems would be struggling with sort of that number of words. We have a much bigger vocabulary than anyone else.
And it's worth pointing out, sorry, just don't mean to cut you off there, but it's worth pointing out for those people that are just listening to this. That's actually picking me up as there as well. It's worth pointing out for people just listening to this that we're seeing the transcription of this happening live as we kind of talk. And so all of those drugs that Ricardo just mentioned were literally transcribed pretty impressively. And what I'm saying right now is also being transcribed pretty impressively as well.
Precisely. And that's sort of, I guess the nice thing is what we've got here too is we're designed to take lots of different accents as well. So whether it be a lot of speech recognition engines are set up to deal very well with sort of like your traditional North American male English speaking voice, whereas what we've looked to do is really broaden that out. So the way I'd usually demo that is so I was born in Mallorca many years ago, lived there till I was 5, but my English accent used to be slightly different. I sounded a lot more Rafa Nadal. So I'm just going to give you a very quick flavor of Rafa, who unfortunately lost the French Open yesterday. I'm a big fan, but see if you see it, for those of you who can see the screen, see if it's easier to understand me or to understand what our engine is transcribing. So I'm going to do the post-match interview that he might have said. For me, it's very, very disappointing to have lost this game. I've not been able to train to the level I want to for the last few months, for the last 2 years, but the sensations are improving, the hip, the legs, everything is feeling better and better. I'm hoping that the following year I will be able to come back to Paris, to Roland Garros. I'd like to congratulate Alexander Zverev on his fantastic performance. But the most important thing for me is that my son, he is 2 years old. I want him to have a memory of me playing tennis. And the best way for me to demonstrate that is to continue practicing using Speechmatics and the fantastic technology that they have to show here.
Wow. So brilliant. There you go.
Stop pitching for you there because I feel otherwise I never stop pitching, but I will take this off screen. But that's a little flavor of what we do. And so as I say, been around for 10 years, 120 people in the business, Cambridge-based company. This is our bread and butter. We do other things as well. We do translation, we do summarization, we do a lot of the classic sort of generative AI capabilities on top of that. But Speechmatics is real differentiation is derived from a real in-depth understanding of audio, which means we get very accurate speech to text, as you saw there, but also things beyond that. And obviously that can be used live or offline. There are hundreds of use cases. We sit as sort of a horizontal platform. We don't specialize in any particular industry. What we prefer to do is allow our end customers, our partners, to build the wrappers and have the links and the cool gimmicks and the GUIs and everything on top of what we do. And we say, you know what, we're just going to focus a huge amount of our research and development into making this engine better and better and better, so that ultimately we can pass the Turing test. And that's a Turing test that at the moment we're looking to pass. I think for me it's on the phone, not quite face to face. We're not doing any of the sort of the image or video creation at this point in time, but everything that is audio related.
Interesting. So passing the Turing test is dependent though on other technologies, isn't it, that sits around the speech recognition? You know, it's the age-old problem of rubbish in, rubbish out. So if it's any kind of voice application or voice user interface and the speech recognition fails, then you're sending rubbish to the language model, and therefore the whole thing breaks down after that. So is it kind of like, in terms of your goals to pass the Turing test, is it that your goal is to create the speech recognition capabilities to be able to have that be feasible with additional technologies, or are you actually also working on the conversational elements on the back end to actually create AI agents and assistants and things like that?
No, it's a great question. And quite honestly, we are not the people building the LLMs. We do not have the budget, the time, nor the inclination to do so. A lot of people have done that very well. Obviously, it's transformed the world, transformed the workplace over the last couple of years, and will continue to do so. But we'll be leveraging lots of different types of LMs. I think in our current investigations and what we're currently doing with it, we're using sort of 3 or 4. Obviously, the sort of the open source stuff like Llama 3, which you can fine tune. We'll do things with that, but we won't be building something from scratch. For us, we see the LLM as sort of the brain that's going to define the future of the workplace. And Speechmatics has a real sort of a real drive to take the input and the output of that and make it as natural as possible. And the thing is, it's not just a simple problem as simple as just hearing, right? Your hearing and understanding of audio goes much deeper than just just your outer ears. Sort of, it is a system that's so complex that it goes straight into the brain. You got the cochlear and the tympanus and the malleus and lots of other bones in the ear that I can't name. But ultimately, it's a very, very complex problem, and making that interaction layer as seamless as possible is what we're focusing on. But that isn't just it's not just the input; it's also on the output side of things as well. And obviously, people like 11 Labs have done a fantastic job on that so far. But we're trying to essentially understand, how do we make this interaction layer as seamless as possible, so that you start to have a conversation that you just want to keep going on and on. I think I don't know. Don't get me wrong. Like, Alexa is great, but we were promised the world with Alexa, and essentially what we got was a glorified sort of light switch, or a glorified sort of alarm clock. What we're actually wanting to do is create conversations that are so innately human that you just want to continue them, much like if you were sort of in the pub with a friend, or sort of in a cafe with, like, well, in any establishment, right? We want to create a conversation so good that it keeps on going.
Definitely. I'd definitely be curious to hear a little bit more about your speech generation stuff as well, but we'll get to that in a sec. Got a very quick question here from Donna. Great demo, looks amazing. Thank you. Does look good. How does it compare to things like Dragon and Fluency Direct?
So I actually haven't heard of Fluency Direct, which is quite bad for me in the speech industry, unless that is sort of a wrapper on top of something like Dragon. But Dragon was very big in the speech industry for speaker-dependent automatic speech recognition. That is to be a system where you trained it on your own voice. So it picked up all of the specific sort of tonalities and pauses, timbre, pitch, tone, etc., so that it could get better and better trained on your own voice. We don't need to do that anymore. And what we are seeing is that people who historically use Dragon, where they'd have to spend like hundreds of hours training it, now just come and use our technology out of the box. There are hundreds of different open source data sets that you can look at across the internet for quality of speech recognition. But when it comes to sort of word error rate, or weighted word error rate, which is two of the key forms for measuring it, then we fundamentally do sit at the top of that quality. But it is important to differentiate. We do sort of large continuous vocabulary speech recognition, which is very much not. You don't have to train it at all. And so we're seeing that we're getting used hugely in the media industry, sort of across TV, so lots of different channels, where they're replacing both the channels directly with a feed from us, but they're also using us with their re-speakers, but they don't need to train their voices for the first time, which lowers the barrier to entry to becoming a re-speaker. And just for clarity, a re-speaker is somebody who essentially watches a TV show and then says what is being said in the TV show, but in a perfect acoustic environment without sort of the background noise of what's going
on. Presumably you would just bypass that entirely, couldn't you? Just send the audio of the program to the model, and that's that.
That's exactly what we're doing, which obviously has huge ramifications, because it reduces the cost of being able to live caption massively, which increases accessibility across the sort of across the industry, really. And what we've seen over the years is that maybe 5, 7 years ago, people would use speech recognition on the lowest quality audio, where there was the lowest quality, so not lowest quality, the lowest viewership shows, where, I don't know, if it's a regional sort of weather program, then doesn't have enough viewers to justify paying somebody lots of money to do it. And so speech recognition would sort of come in at the bottom rung and then sort of move up and up and up, and then start to replace some of these more human use cases. Now, obviously, for your offline stuff where you've got massive budgets, so I doubt you'd ever use speech recognition to sort of do your next Hollywood blockbuster, just because you have enough money to sort of get it transcribed by a human, checked 4 or 5 different times, et cetera, et cetera. But everything where there's a cost environment to it, you'd use speech recognition. And obviously the advantage there too is that we are superhuman in so much as we can produce the transcription more quickly than a human would ever be able to.
Yeah, definitely. Apparently Fluency Direct is from a company called 3M. I'd never actually heard of that myself, to be honest. But anyway, there you go.
We'll look them up afterwards.
Say again?
I'll look them up afterwards.
Yeah, same here. Yeah, it seems as they do speech recognition anyway. Cool, that's great. So you mentioned there that, you know, it doesn't require further training, doesn't need to be trained on a specific voice. We were talking a little bit earlier before we got started about the kind of use case where you're working on something, and we'll get into the more details a bit around being able to recognize who's speaking and separate what might be background noise like the TV on and then who's speaking. So that's an issue that we've had in the call center, for example. If you create a voice assistant in the call center, it's always picking up the TV in the background, and it's picking up someone in behind the person shouting or whatever. So being able to isolate who is speaking and focus on that is really great. But is it one model that you have in terms of behind the scenes what's going on? When you click that translate button there or the transcribe button there and you start talking, is it one model and you're training this one model to do all of this kind of different stuff, different use cases requiring potentially different acoustic models and things like that, like a telephony use case versus a media use case where your audio signals better quality versus poor quality, all that kind of stuff? Are you thinking, is this just one model? Is it a series of models? How do you approach solving this generalized speech recognition problem?
Yeah, it's a great question, because there's been a lot of different sort of philosophies on that in the past. As the engines have improved, the need for more models has reduced. Everyone used to split up their 8 kilohertz model from their 16 kilohertz model. So whether it's telephony or not, we used to do the same. We haven't done that for about 5 years now because our base model has become so good. The way we build is quite unique in the market. So what we tend to do is we train essentially a self-supervised body, is what our ML team likes to call it. Sorry, our AI team. You don't call it ML anymore. I like to call it AI. But our ML team will train a self-supervised body on millions of hours of unlabeled data. And these millions of hours of unlabeled data will contain languages from all over the world. And what that means is that I like to compare it to sort of taking a small child and putting them in a different country, obviously fed and watered and cared for with their parents, etc., etc. But giving them that exposure to a different language. So if you'd gone and lived in France for 6 months when you were 3 years old, you wouldn't be doing French lessons per se, but you would be sort of picking up sort of the accent, the noise, the words, etc., etc. So that's what we do as well. We essentially build a model that travels around the world, listens to every type of language, and then we will build specific models for each language themselves. So we will train it with an amount of Spanish data, an amount of French data, or Italian, or Mandarin, or Dutch, or Swahili, whatever it might be. And then that will become our language-specific model. The good news about that is it means we can use far less training data compared to other people in the market. We reckon we get to the same level of quality on about 100 times less data, which means more efficient models, faster models. But it also means that you become better at that background noise that you were talking about, the ability to distinguish between what's going on in the background, to be able to pick things up amongst things that aren't speech, so amongst the crashing of waves or traffic in the background. And that's how we build our engine. But to focus on the model question, one model for both 8 kilohertz and 16 kilohertz, we do differentiate by language. And we do that because we believe there's no free lunch in machine learning. And actually, if you put too many models into one single one, then it can cause it to hallucinate or start thinking that you're doing one language or another. The path we have gone down is bilingual models. So we have a model where you can switch from English to Spanish very seamlessly, and that works particularly well for around translation use cases. But in general, it's one type of model for different languages. We offer a faster version, so a standard and enhanced version. So for some people who just want quick as possible, cheap as possible to get out, fine. For others, those who want the most accurate possible transcription, we serve them too. But we try to give as much capability to the user in the market. And I think you're describing the use case of people talking in contact centers in the background. We have a few sort of fixes for that too. So one of them is we give the ability to the end user to call out to a system at what level of decibel do you actually want to listen to what's being heard. So it might say, you know what, we want anything that's coming from the mic from the person who's being spoken here, we listen to that, but anything below 30 decibels, just ignore it, don't transcribe that, just transcribe the other channels so you don't get this crosstalk problem. Alternately, we can also use the diarizations of the automated speaker change to be able to say, hey, recognize only the first speaker's voice and no one else's. So I've got some great demos at the moment where, again, the stuff we've done working with a conversational agent, I can start talking to it, and then I can literally have an entire group of people have a conversation next to me. It won't transcribe a word until I talk to it again, which is, for me, very exciting to be able to see.
That's very interesting. So you referenced Alexa earlier on. So Amazon was and even Google Assistant had similar technologies to this, but they didn't end up getting into a production ready state as such. I think they might have trialed it in beta or whatever, but essentially it was to do with speaker identification, but the way that they framed it was almost like one lens was like a personalization lens, and the other lens was an authentication lens. So the use case that they were talking about is, for example, if I ask Alexa to play some music, then it would play my playlist, versus if my wife did the same, then it would play her playlist. And then Google's use case was that if my son tries to order, 50 kilos of ice cream, then it won't let him, because that voice isn't authenticated to make a purchase, whereas my voice is, and therefore it was me doing it, then it would kind of work. And so there's kind of been examples of trying to get this off the ground in the past. And so what do you think of is the sort of the benefit of that particular use case? Is it either one, making the user experience better, which obviously it will do, because if you've got a voice assistant in the contact center, then you only want to pick up on the person that's speaking, not the background noise. Two, is it a personalization thing? So that, for example, if you're voice enabling an app, let's say you're Spotify, you've got multiple people using an iPad in the house, being able to customize what happens based on who's talking. Or is it an authentication thing, which is, not necessarily voice biometrics, but I don't suppose it's that much different, because you can recognize the person's voice and separate it from other voices. So curious to get your thoughts in terms of, like, is it a combination of all three depending on the use case, or is there a particular reason why that speaker identification thing works better in certain contexts?
Yeah, big question. I'd say on the biometric side of things, so we've seen some flip-flopping in biometrics as to whether people want to use them or not, because obviously with the whole advent of sort of the leaps in generative AI, the ability to be fraudulent or copy someone's voice means that I think we've seen a bit of a step back away from that. I mean, obviously you saw the whole Sky stuff with OpenAI, and so the closeness of that voice and similarity. For me, that's an area we're not playing in, and we also think we're almost sort of sitting back and seeing what tends to happen there. I think obviously if you've got your own phone, being able to personalize it to your own audio fingerprint for specific use cases within like the confines of your house or sort of a closed system, that's definitely a safer way to do it. And what we'd be looking at is sort of just the defining factors that make audio specific to somebody's voice. But then you also get into sort of a bit of a sticky situation where you don't want to be keeping people's voice data. It gets into a lot of GDPR and sort of issues around it as well. So it's something that we've tended to take a bit of a step back on and steer clear from, and just said, you know what, we're going to try and identify audio-based information that isn't speech from scratch within the audio file or the audio stream that we're getting. And that leads us into sort of some very cool stuff around audio tokenization and audio language modeling that we can get onto later on. But in terms of the biometric side of things, I think we sort of need to watch the space a little bit, because I feel legislation, GDPR, etc., is going to be competing quite strongly with what the art of the possible is.
Yeah, I agree with that. I think that a lot of the biometric companies that have had a great deal of success recently, the pin drops of the world and stuff like that, and now they've got models where they can, sniff out synthetic voices versus real voices and all that kind of stuff. I don't think that the regulators are even aware that technology exists because they've been so distracted by the whole large language model thing, and how do we kind of make sure that this is all done safely and securely, that I think that voice biometrics is definitely something that will become under the microscope at some point. So probably a good idea to stay clear of that. Definitely, I want to get onto audio language modeling, because that's really interesting. But first, how do you see and perceive some of the other companies in this space, like the big tech companies? And OpenAI is not a big tech company. However, it's got a lot of funding, and it is solely focused on doing one thing, basically, which is creating general AI, artificial general intelligence, which requires other components beyond a language model, because as you saw, as you've alluded to a couple of times, the OpenAI demo that was made a couple of weeks back, there's a very big voice player there. Google, Gemini and Gemini Pro, very much the same sort of lens. For Google, the question is what happens with Google Assistant, and is Gemini another version of Google Assistant 2.0? Does ChatGPT try and move into a space where Alexa was? Essentially, it's like all the time, even in the early 2000s with Tell Me, there's always been this kind of urge and direction and attempt to create a personal assistant. And OpenAI's kind of focus on doing that has led it into creating things like the voice you mentioned, led it into creating things like the Whisper speech recognition model. And if you look at the way that all the big tech companies tend to operate when they provide these models, is that they've got so much resources, so much computing resource, so much financial resource, that they tend to just make things better all the time. And then hopefully the idea of that is that it drives down price over time, so that these technologies just become totally commoditized. Image recognition, speech recognition, language understanding, language generation, all that kind of stuff. It seems as though one direction is that the Googles and OpenAIs just keep on making this stuff so much better and so much cheaper that it gets quite difficult to sort of, for the choice to be made as to what other technologies should we use, or why don't we just use OpenAI? How are you thinking about that kind of process? Because for Speechmatics, you've got a very solid discipline in a very specific area. I would actually argue that having a solid discipline in a very specific area is better than being very general, spread across loads of different things, which OpenAI obviously is. But how do you, when Whisper's released and stuff like that, how do you assess how these large companies, very, very heavily funded companies, are approaching this kind of stuff?
Yeah, the way we approach it, I'll tell you what, so Speechmatics started sort of commercialized 2014. 2016 is, I think, when we saw Google sort of pop up on our radar in the space. And at that point, as in I was fairly early on into my career, and I was like, all right, well, this is curtains. We're done. I mean, if Google's getting involved, what can we do? And I think what I learned from that is that, again, being a specialist, focusing on what you're doing means you can continually improve. And what we've also found is that the bar, and I keep doing this, but the bar for improving completely changes consistently as well. And as the speech recognition gets, and this could be for others, not just speech recognition, but referring to that in general, as that gets better, as it gets cheaper, it opens up new use cases that weren't there beforehand. I think about this in terms of, yes, it becomes acceptable for sort of, like we said before, right? It becomes acceptable for captioning for this TV show that's only got sort of 100 viewers, or it becomes acceptable for sort of a phonetic search within your most basic offline sort of contact center capability. But actually, it can become its own agent. It can then sort of it can become the interface that we use with our PCs, with our laptops. I mean, if we move away entirely from a sort of a keyboard based sort of input, is it going to mean that, the LLM improvements and the speech recognition, does that mean I'm going to be able to get to a level to be able to code without even being able to type? So for me, like, the use case is always improved, and you've got to continue to fight and search for those new opportunities that appear as the other ones become slightly more commoditized. And then there's also things like there's difficult accents, there's background noise, there's different languages, sort of lower resource languages. I mean, LLMs are sort of, they do very well for English, but they don't do well beyond that. So I still think there's a panoply of different use cases, and they keep on appearing. And you wouldn't trust a speech recognition system to be the sole interaction for sort of a life and death sort of a live speech recognition system for a life and death legal situation, or sort of in an operating theatre, just because of the danger of making errors. So until I just see that as quality improves, new use cases open, as cost comes down, you can start to listen to more things. So you can start saying, you know what, we weren't going to transcribe that earlier, but now we can listen to every single podcast that's on all of these shows, because we can get this amazing insight into everything. And yeah, that would have been too expensive to do 2-3 years ago, but now we can start to track our viewers and understand them better. So I do see that there's continual improvement. And then on that as well is, as you become better, as you become more efficient, you can then start to shrink things as well. So we're looking at sort of the conversational AI stuff that's out there, the stuff from OpenAI. Like, as in, we see a path to being able to run that very effectively on device. So you haven't got everyone's talking about sort of like cloud compute costs, everyone's talking about sort of latency, everyone's talking about sort of not being able to get the network that you need to do. We could take that all off the table and just say, you know what, the LLM, the speech recognition, the text to speech, that's all going to run on, it's all going to run on your laptop, it's all going to run on your phone. That's another challenge, and being efficient enough to do that is like another frontier that you can push through as well. So for me, being a specialist means that you can get to these better, more efficient, cheaper use cases, and newly appearing use cases more quickly.
Yeah, definitely. And I think that the use case focus is really interesting as well, because there are so many things that make certain use cases difficult. So, for example, a voice enabling an app has different requirements to voice enabling a call, doesn't it? Because if there's a bit of a delay on the transcription and the response in an app, it's not really the end of the world. You can mask it with some other things. Whereas on a phone call, if there's 3 seconds goes by while the speech recognition's working and then the model's working, then a response is coming back or an API call is being made, it's crucial to have every element of that pipeline being super low latency. And then, as you mentioned earlier, an 8 kilohertz signal over the phone might require something different to a 16 kilohertz signal or on an app or whatever. And every use case is going to have different things like that, isn't it? That mean that for certain use cases to be enabled, certain very specific things need to be accomplished. And one of those things is, in all instances, I would say, is barging. We saw the demo from OpenAI the other week where you could barge into ChatGPT and stop it in its tracks when it's talking, and it will recognize that you're talking and all that kind of stuff. So the two things that I've never really seen done that effectively, including in that demo, which everyone was raving about, but actually there was a lot of room for improvement in that, barging and end of speech detection. So most systems rely on detecting silence for end of speech detection. That ends up potentially being a bit of a clunky experience because it will start responding before you've finished speaking if you just pause for a slight minute while you think. And in a voice interface, that thinking time can be important, because if you're under pressure to say something, sometimes you do need to consider what you're saying. And then the barging side of things as well is you need to be listening while you're talking sort of thing. So I'm wondering if you've got any insights or any ways that Speechmatics is approaching those two areas that would help people understand what the importance of getting those things right is, how you get those things right anyway, because as I said, the OpenAI demo on the face of it looks good, but when you look at it again, there's a lot that could be improved there.
Yeah, and I've spent, again, as we've been playing around with our own conversational AI, I've spent a lot of time talking to the OpenAI one too. And I was having this very debate with our chief product officer today. I find the end of sentence stuff incredibly frustrating, because if I'd left that pause there, it would have interrupted me. And
Yeah.
I knew not to, but because I'd used the word because there, because you had extra context around it. And for me, it's one of the most frustrating things. You're just there. And to be honest, when you have an actual interaction with a human being, you haven't planned out what you're going to say. And I'm sure everybody in that demo had their scripts they'd put together that had been perfectly set up, so there wouldn't be gaps, there wouldn't be any sort of interruptions, or at least minimal interruptions. But actually, when you're thinking about things, you think out loud, and you don't want to feel this sort of this innate pressure to finish what you're saying. And you almost start just putting filler words in so that you don't get interrupted beforehand. So on the one hand, you want really, really low latency. So you want to get the speech recognition done as quickly as possible, but you also want to be resubmitting what's being said constantly. So, I mean, the way our engine works, we offer the partial transcription and the final transcription. So you're recontextualizing what's being said. Then you also want to be setting it up to give a bit more delay to actually allow us to act as human beings. And one of the areas of the research that we're doing that is very exciting around this is taking more than just the more than just the speech in the speech recognition. So we can already do things like recognize applause and laughter and coughing, and we've got some demos running around sort of language modeling for audio as well, where you can start running audio through it, and you can say, hey, there's a helicopter in the background, or a car engine's being revved as sort of a lady laughs, and then I don't know, a penguin jumps into a swimming pool. Probably not the penguin into a swimming pool, but as in there is that description level of things. However, you can also take it into a much more simple use case, which is understanding the tone of what I'm saying in my words in such a way that even though I say things like this with little pauses, even if we were having this as a phone conversation, you would not be interrupting me, because there is an element in the audio that I have there which says, wait, there's more gold to come, or in my case, rubbish to come. that is the key bit that we're starting to play around with. So actually saying, you know what, for your assistant use cases, when you're trying to put a shopping list together, you don't know, like, I can't remember the first thing on my shopping list, right? So how on earth am I going to get all of that right? And I don't want to be prompted as like, oh, and what's next, and what's next, and what's next. You want to have that naturalness around to pause. Obviously, if you're chaining together speech text, speech recognition, going over to like a sales agent who's then like searching something up automated, you've got an LLM and TTS, which is taking a while, then you want to make sure the speech recognition is happening as quickly as possible. But you also want to start to input non-speech audio information into that, which makes it a more human interaction.
Is it just audio that you're listening for there though? So like in those few examples that you just gave, where you're in the middle of talking and you'll pause like that, and you know that I'm not finished, I know you're not finished, etc. Is it just the audio that you can do that on? Is it because that I can see you and I know that you're in the middle of talking, and maybe as you gaze away as you think, or you look up as you start to think, like is there other cues that we're missing, or can we do that stuff purely just by listening for the signals in the audio?
In my view, it's the signals in some of the words, and it is the signals in the audio. And again, the argument I had today was, oh no, well, you've got the video, you can see what's going on, that's why you're not interrupting someone. I guarantee if we had this conversation for the next minute and a half with our eyes closed, which might be a first on your podcast, that we still probably wouldn't be interrupting each other.
Yeah, that's fair enough. Yeah.
So it is, I think it's part of it is in the words, because obviously if I say, and then you're waiting for something more, but it's also in the intonation, because I'd say, this sentence is over, definitely done. This sentence is over, you're waiting for more again. So there's a huge amount that can still be explored there. And for me, it's a really green space in this area. And it's something that we're excited about, because we've got all of these millions of hours of audio. So understanding that speech is just, it's a treasure trove that hasn't hasn't been mined yet, because everyone's been so focused on just getting the words out.
Yeah, I would definitely agree with that. I think if you can crack that, you're onto an absolute winner. Like my theory, and I don't know if this is true, but I don't know if you have any other information on it. I know we'd spoke about this very briefly in the past, which is that my theory for how OpenAI gets as much accuracy from Whisper compared to like AWS, for example, is that when it receives the audio, it's also sending the text it's transcribing to a large language model, and using the large language model's contextual awareness of what words would naturally come together in a sentence to be able to account for what would typically be the word error rate that happens. Because if you can understand the structure of the sentence, then you can retrospectively go through that, or even in real time potentially, and say, right, this person is saying this, and the chance that the next word is therefore is higher because I understand the pattern of language. So like, I don't know if you had any insight into that more than I do, or whether you do something similar, because a lot of the stuff that you're saying there in terms of detecting end of speech, which is I think a crucial part of getting speech or voice user interfaces right. A lot of what you're saying there is the audio, but I think the context of the sentence and understanding the sentence would probably benefit you immensely, wouldn't it, in terms of being able to predict whether the sentence is over or not? Like, so I don't know whether, one, is that the way you think OpenAI does stuff like this? And two, is that something that kind of you do as well to give yourself further understanding of the sentence, or do you not need to do that?
Yeah, and so what you've described there in a way is a little bit of the evolution of speech recognition over the years. Beforehand, like we were doing a lot of language modeling, so we didn't call it large language modeling, but we were training large language models back in 2014, 2015, based on recurrent neural networks, so that we were very good at guessing what the next sentence and the next word was in a sentence. Exactly as you described. If I say the cat sat on the, then your brain is probably going to say Matt if you've grown up in an English-speaking environment. And that is so the way our engine has always worked is we'll sort of run the acoustic model, which will listen like the ears essentially of the engine. What did I think was said? I think it was X, Y, and Z. The cat sat on the, let's say rat, for example. And then the language model goes through and says, okay, well, based on historical probabilities that I've got, yeah, the cat sat on the rat is fine, but I'm not quite sure what it was. The Matt is a more likely outcome, and based on the weightings of the probability, it will correct that way. I can share a story from the early days, which is when this is very, very early days before we had sort of user testing and QA and all of that stuff. But we updated our cloud model, and we had a really, really good language model, so a really good understanding of context. So our perplexity scores were very good. So we were very good at guessing what the next word was, but we overweighted it in our decode at the end of the speech recognition, which meant that our engine essentially stopped listening to what was being said and started just saying what it thought should be said based on what the most likely thing in the next sentence was. So you could put up anything and it would just give us complete gibberish. So again, that got caught within about 2 hours, and that was very early days, very startup-y stuff. But yeah, that's exactly how speech recognition is done by us. Beforehand, instead of using a language model, you'd have an n-gram, and some models still run an n-gram first. So n-gram standing for the number of words. You might have 4 words or 5 words, sort of context going back and forwards. A lot of providers now do an end-to-end model, which sort of brings all of this together, sort of in the training period. But we found that how you described it, the acoustic model plus the language model separately, followed by decode, still works best for us. But yeah, so that's sort of a bit of context on the history of speech recognition.
Interesting, yeah. And you spoke a lot, alluded to audio language modeling, which you kind of alluded to some use cases, detecting laughter and applause and stuff like that. And I know that, again, Alexa had something that came out a while ago now, quite a few years ago, where it would do things like, and I never saw this work it, and I never saw anything beyond the press release, or whether it actually does, I don't know. But it was stuff like detecting that your window had been broken, therefore maybe there's an intruder, therefore it'll alert you as to the fact that you might be getting broken into. So there's a lot of really good use cases that you would be able to find by being able to recognize other audio markers, not just language. And also, I wonder whether there's also a kind of music kind of post-production and audio post-production benefit here, which is if you can recognize a cough or a clapping or somebody sitting on a chair, and you're in the middle of you created a film, there's some sound in there that you don't want, but it's happening at the same time as the sound that you do want. Being able to split those apart seems as though it might be a similar kind of technology or something like that. I don't know. I wonder whether anyway you can share more about what your approach is to audio language modeling, what's different to speech recognition, and maybe some of the use cases that you're noticing in that space.
Yeah, so for the audio language modeling, what we're looking at is basically what is describing in words what is happening in audio that isn't text. So the events that we do right now, as we said before, are the laughter, the applause, so things like coughing, etc., etc. And then that moves into far more complex things. As I look at it, so the breaking of a window, obviously, that's incredibly useful. I don't know when that technology was brought out by Alexa. I imagine it's probably moved a long way since then. And then, obviously, the nice thing about all of this is you can just tag the information. If you tag the information, it's like this is speech, this is non-speech. So we will go through an audio file and we say, okay, this is music, ignore the music. Unless it's rap, and rap is sort of in that interesting thing. It's like, do you want to transcribe the rap? Do you not? But you can go through. You could say, okay, this is not speech, this is music. Actually, you want to push this into a different filter that works out what the song is, and so actually that can be tagged for the artist, etc. Or you can say, here are all the non-speech things you might want to look at. Decide if you want to remove all non-speech information, and that's not something that we do nowadays. But there are certainly people who do sort of audio cleaning, who would love to get their hands on the essentially that core information, so that then they can can clean it up, and as you say, split in different channels, mix it down in the ways they want to. So the ability to do that is improving a huge amount. I think there was the audio LM paper I think it was last year, was the salmon paper. You can look it up. It's a salmon, but with double N, I think. And that's like what inspired a lot of the work that's gone into this since then. And I do think it's going to be like the next frontier within speech. That's funny to say. The next frontier within speech is not going to be speech, but it won't be the word element of the speech. It'll be all of the things surrounding it.
Interesting. Yeah, it's so in your case, you're talking about you would use language to describe the additional bits of audio that are happening as well as the speech.
Yeah, and just to be clear, so just for the product team, kill me. This isn't something we have released yet.
Yeah.
Apart from we've done it for the very basic stuff. So I think applause, laughter, that sort of thing. We've got demonstrations of us doing it for describing everything. But yeah, imagine if you were with somebody who was deaf, and essentially you needed to be able to describe what they were hearing in text. Creating that automatically is what we'd be doing through the audio LM.
Interesting. Yeah. So that would definitely be really beneficial in that media use case you mentioned, where you're doing the transcripts for films and TV programs and stuff like that. Are there any other use cases that you're thinking of for that?
I mean, I definitely think, again, I know we've been going on about conversational agents, but creating a more human interaction there for sure. You being able to use it to get a better transcript. I mean, on if you're looking at if you can differentiate between background chatter on a call and sort of what is actually the main speech channel, and being able to demarcate between those two, that would be incredibly valuable. Probably sit down and come up with hundreds of use cases. They're not coming to mind right now.
Yeah.
But yeah, it is that next level down of information, which frankly, just give it to our customers, and I'm sure they'll find something to do with it exciting soon.
No, definitely. Yeah, I think that use case of removing background noise would be, so beneficial. If you can remove background noise from an audio signal because you can recognize what speech is versus what speech isn't, therefore every input into a language model gets inherently better because you're not messing around with any of the other stuff that could confuse it. And so that sounds good. So before we began, you were talking about some of the conversations you've been having recently with various companies and how they are kind of saying that the bottleneck to AI progress right now is speech. Maybe we might have covered in this conversation so far some of the reasons why that might have happened, but maybe it's not directly. Can you fill us in on what those conversations have been and why is speech the bottleneck in terms of AI progress at the moment?
Yeah, I don't know if I can name specific company names. I can probably describe them, but
yeah, that's all right.
The big tech companies across everything from manufacturing devices to the chip players to anyone who might want speech and interface, language models have got to a point where they're pretty good. They're doing a lot very well, but it's not a natural interface with the speech. It's still causing errors. It's still causing frustration. People want the speech recognition to be good for two reasons. One, we've sort of hit a bit of an asymptote on training data. I mean, I think the OpenAI release, right? A lot of people were waiting for GPT-5. It feels like the whole sort of double the amount of data and gets an improved model is reached a point where it's not improving at the level it wants to. You look at how quickly Llama 3 has improved and got close to that, or something that is open source that's running sort of on device. It feels like there is a need for more textual data. And I don't know if you've been following some of the amusing sort of Google search, AI-powered Google search stuff from this week as well.
Yeah.
Some of the mistakes there, right? That is because there is not enough clean data around. And so you essentially, whether you're picking it up off Reddit or who knows where, that's happening because the data is being generated that isn't clean. And so we do have this funny situation where actually more of the text that's being generated now is not going to be perfect text, so it's going to make language models even worse. Speech needs to be the way to get genuine human conversations, because we've got lots of text data, but we haven't got anywhere near as much conversational data. because most conversations are had like this, right? So being able to get a 99% accurate transcript from the conversation we've had today is absolute gold to all of those LLM providers to be able to continually train, improve, and differentiate their models. So that's one side of things. And then the other is just coming down to the fact that, again, speech is running speech for everybody sort of is either going to be, it's still going to be expensive. It's still going to, if you want to sort of have it to the point where it's the interface you've got on your phone and you're using it all day, you don't want it to be ideally you don't want it to be going online. Ideally, you don't want it to be sort of running down your battery. So you need these models to be as efficient as possible. And at the moment, it feels like everything that's being demoed is using sort of the cloud-based model, sort of that's as big as possible to be as accurate as possible. And it's still not there on the quality. It's still not there on sort of the accent robustness. It's still not there on the understanding of different languages. So I sort of see sort of two stages there. One is get the quality good enough, and then there's going to be a race to get it efficient enough to be able to be used in everyday life a lot as your first port of call for interaction with whatever technology you're working with.
Yeah, and I still believe now, and I thought this when I first saw Alexa, is that voice is going to become, and however long it takes is however long it takes. We've kind of already been through the Alexa kind of thing, and it kind of got going. It got to a certain point, and then it kind of hit a kind of a plateau sort of thing. And now, Google, OpenAI, they're kind of bringing back the voice interface, and so at some point it'll get there. But yeah, as you kind of alluded to, the gap in getting there is that the speech recognition needs to be spot on, because you can't afford to mess something up. If that was Alexa's problem, basically, is that 9 times out of 10 what you said to it didn't understand. And sometimes that was because of the fact that it just didn't have the information at hand, but also it was sometimes it thought it didn't actually think that you were saying the thing that you actually said. And so it's definitely a bottleneck there. One of the things that you must be considering, kind of obviously always, but probably more so now given the heightened kind of attention from government bodies and media and all that kind of stuff, is that whole kind of concept of data management, where you get your data from, where is it stored, how is it used, is there permissions behind it, and all that kind of stuff. And that's one of the things that OpenAI just got themselves into some shit with, and we haven't seen the end of that yet in terms of the Scarlett Johansson potential voice. Alexa had the exact same problem. People found out that it was sending recordings off to the Philippines to be transcribed or to be labeled and stuff like that, and people weren't happy about that. So there's always been these sort of like data scandals with all AI companies that doesn't do anything for trust, doesn't do anything for getting this technology at a prime time sort of standard. And so how do you approach data collection? Because one, you need data to train your models. So you're going to have to get data from somewhere. And then 2, you need, all that you do is process data because it's all people talking to it, which if you look at some of the research like from Canary Speech and companies like that, which is that there are more data points in your speech than there are in your DNA, apparently. And so speech is like super sensitive data, even if it's not really seen as such. So what's your kind of approach to, 1, for finding and sourcing training data, and then 2, the processing of the audio that you spend all of your time doing?
Yeah, and obviously we're incredibly careful about it, because it's the kind of stuff that if you get it wrong, it can tear your company apart. So we have we have data arrangements with customers for whom they've agreed to give us data, and so we've made very carefully that legally everyone was able to own the data, and that can be done. And that's how some models have been built. Because we've been doing speech recognition for that long, it means that we've been able to build up a pretty good corpus across those different customer bases. In certain cases, we bought data publicly as well. For the language model side of things, you can train on a lot of stuff that, again, you check is available and legal to use. But we've essentially been able to buy, partner, and then take what is open source and free for data. In terms of our customers, though, we make sure absolutely clearly that sort of if they do want to give us any data, that they are very clear about that they want to do so, and our default position is not to do so, right? So we have I'd say of our customer base in general, the number of hours we transcribe, the vast majority is actually not transcribed on the cloud still. It's still transcribed on our customer services. And so you essentially take away that problem. But the way I think you fully take away that problem is you build models that are efficient to run on as small a footprint as possible. So like what we do really well is we're very good at building very accurate large models and then shrinking them down and putting them on device. And so what we'd say is, if your speech recognition on your phone is only running on your phone's GPU or your CPU or whatever, if it's not running in the cloud natively, the data doesn't need to go anywhere. It can be deleted. You can maintain a memory of yourself if you want on it, but that's how I think you ultimately solve it. So from our point of view, yes, we offer cloud. We give the ability to delete automatically, delete after X number of days. People can choose that. But for the vast majority of people who use us, their data, everything gets deleted. You run it on premise, and you've got no issue there whatsoever.
Yeah, that's the ideal kind of future state, isn't it? Really, that the speech recognition happens on the edge. Therefore, it's faster, takes out any kind of concern regarding latency, all that kind of stuff. Much better for the user experience. Much better for you, because you're paying less cloud fees. Probably much better. We've been doing a lot of stuff around sustainability lately with a client, and the language models obviously are massively compute intensive. And therefore, I don't know how compute intensive speech recognition models are, but there's something going on there. So maybe if you can get it onto a device and you can make it be more efficient, then you're not consuming anywhere near as much power to do it, are you?
Well, exactly, and we can run speech recognition models on like hundreds of megabytes of footprint as opposed to gigabytes, which most people do. So that is already far more efficient. But you hit the nail on the head, as in reduce the size, reduce the memory footprint. Don't put it if you can take it out of the cloud, even better. I mean, and don't get me wrong, most of our revenue is generated from people who either use our cloud or take our engine and then run it in their own cloud or on their own tin. But we're increasingly seeing that the requirement for on-premise, for on-device, on the edge, just makes so much more sense. That is the next frontier in speech recognition. Get it to be good enough that it is better than humans, get it to be working across all of those languages, and then get it running as efficiently as possible, where it's not destroying the planet through energy consumption, draining your phone battery, or sending your data off somewhere else.
Yeah. Perfect. Perfectly put. Ricardo, this has been absolutely fantastic. Thank you so much for joining me. It's been an absolute pleasure. We'll put all of the links to Speechmatic resources, etc. in the show notes. We'll put your details in there as well for LinkedIn if you're happy with people to connect with you. And it's been absolutely fantastic. Thank you so much for joining us.
No, pleasure to speak to you, Kane. Really enjoyed it. And as I say, I've been doing it for 10 years. Absolutely love it. And really excited to see where the industry goes next as well.
Definitely. I think it's a perfect time. I mean, it's one of those things, isn't it, where it takes something like ChatGPT to kind of wake the world up to all of the hard work that's been going on for decades in this kind of space. And I think that, we'll start to see now that OpenAI has got everyone's attention. Google is, clambering around, as it was, a fast follower, as it was with Alexa and Google Assistant. Google was a fast follower behind, always trying to keep itself into the race. And now this whole kind of idea of who's got the best models and all this kind of stuff, the arms race is well and truly on. But for some use cases, it makes sense to have a text-based interaction. If you're sitting down, you're doing some deep work alongside ChatGPT, you're sending it files, you're having it analyze stuff, that's great. But one of the kind of promises of AI is that it really should just blend into the background, and the whole idea of AI will eat software is exactly that, which is you should be able to access it from any device, wherever you are, internet connection or not, and speech recognition is a crucial fundamental part of that. And so it's great to see and hear that, yes, you've been in this space for a long time, and the technology is ready for prime time, but it's also it's a a perfect timing to have this capability meet these now powerful models to be able to create and enable the use cases that we've been, dreaming of and shouting about for the last quite number of years.
Yeah, no, for sure. And I think for us, what OpenAI has done is it's made people realize how good the technology is. If we can show some extra differentiation on that, then it just essentially does wonders for our marketing, because their marketing team, or at least their marketing scope, is a bit bigger than ours. So for us, it's helpful to make people realize how good this technology is, what it can achieve. And again, it's going to be in everything, right? As in, you look at the smart glasses that are coming, the buds, sort of, unless we say, I mean, I don't want to go all sort of Terminator or Skynet on us, but sort of like the interaction with robots as well, automotive. There's just going to be countless use cases that need to have that seamless, as you say, assistive. I almost prefer assistive AI to sort of generative AI in some ways, because it's supposed to make our life easier and better. But just have that running in the background to make life easier, make it simpler, not be sort of massive models, but just something that is there, making things better, hopefully.
Yeah. Indeed. Amen. Thank you so much for that. Really appreciate it. Thank you for joining us. And yeah, don't forget, UNPARSED is coming up. It's like 3 weeks away. Get your tickets right now, unparsedconf.com. Use the promo code VUXWorld, all capital letters, all one word. Save yourself a few quid. And we'll see you there. Thank you, Ricardo. It's been an absolute pleasure. And thank you all for joining us. And we'll see you on the next one.